Hi, this is 5.5 part 3, and I stopped off at example 6. So example 6 says find the following indefinite integral, x times the quantity square root of x minus 1 dx. Once again, if I look at this, I don't have any rules that apply that I can use. So I'm going to try substitution. So the first thing I'm going to do is rewrite this guy as the square root of x minus 1 times x dx. And then I'm going to guess that the substitution is u equals x minus 1. Okay, so if I take the derivative of both sides, I get du equals dx. And this is a problem because I have x dx. Now remember before, I said you couldn't really multiply by anything but a constant, but if I wanted to make the leftover look like the dx, I would multiply both sides by x. So if I did that, I get x du equals x dx. Now if I check that out, I have issues right here because I have x with a du. Now remember, when we use u substitution, when we integrate, everything has to be in terms of u. So we have to be clever. And what we're going to do is look at this first line here, which says let u equal x minus 1. Well, what I can also say is I can move the 1 over to the other side. So I can also get u plus 1 equals x, right? And if I do that, I can put this like this. U plus 1 du equals x dx. Okay, now I'm ready to rock and roll. So let's go ahead and do this next step, which is to write. So if we write this out, so we have the square root of x minus 1 is going to turn into the integration of u to the 1/2, and then I have times u plus 1 du. Okay, now I'm going to have to do some work on this because I'm basically going to have to distribute the u to the 1/2 power. So when I do that, I get u to the 1/2 times u to the 1, and that'll give me u to the 3/2, and then I get u to the 1/2 times a positive 1, which is u to the 1/2, and then I have du. Okay, so I'm going to integrate it now. So remember, I'm going to get u to the 3/2 plus 1, which is 2 over 2, and that'll get me 5/2 in the denominator, plus u to the 1/2 plus 1, which is 2 over 2, so u to the 3/2 power, plus c. So what does this look like? This looks like 2/5 u to the 5/2 power, plus, and by the way, I shouldn't have a u in the denominator. I don't know why I did that. So let me fix that really quick. 2/3 u to the 3/2 power plus c. Okay, now I'm ready to back substitute. So remember that u equals x minus 1. So my answer is going to be 2/5 times x minus 1 to the 5/2 plus 2/3 times x minus 1 raised to the 3/2 plus the constant c. Okay? All right. So let's look at example 7. Example 7 says solve the initial value problem dy dt equals sine of the square root of t divided by t when y at 0 equals -5. Okay, we're starting off with a derivative. So to get back to the initial value, this here, we have to take the integration, take and do integration. Okay? All right, so we're going to take and do integration with this. So basically what I'm going to do is I'm going to integrate. Yikes, sorry about this. It's like jumping around. sine, and I'm going to write this as t to the 1/2 over t to the 1/2 dt. Okay, so when I do that, what I want to do is, I'm looking at it and I don't have any rules that match up with it, so I'm going to use substitution. So I'm going to substitute in, I'm going to let u equal t to the 1/2 power. Okay, so if I do that, I get du equals 1/2 t to the negative 1/2. Okay, all right. So my original function, if I rewrote it, I'd write it out as sine t to the 1/2 times t to the negative 1/2 dt. Okay, so if I rewrite that and I look at the leftovers, so the leftovers are from here over, I've got a problem because I have 1/2 t to the negative 1/2. So I got to multiply both sides by 2, so I get 2 du times 2 times 1/2 t to the negative 1/2. So t du equals t to the negative 1/2. Okay, so now I'm ready to write this in terms of u. So this becomes sine of u times 2 du. Okay, so I'm going to pop the 2 out, and I'm going to integrate this. Okay, so if I integrate 2 times the integration of sine u, we get cosine u. Remember, it's negative, so I'm going to put the negative out front there, plus c. Okay, and next we have to do back substitution. Remember, u equals the square root of t. So if I write that out, I get negative 2 cosine square root of t plus c. Okay, normally I would be done, but since this is an initial value problem, I need to find or use the initial conditions to figure out what c is. Okay, so if my function y equals negative 2 cosine radical t plus c, we know that when x equals 0, y equals negative 5, and that's given right up here with this initial condition. So I just highlighted where I got this information. Okay, so I'm just going to plug in and chug. Wherever I see y, I'm going to plug in negative 5, and then wherever I see t, I'm going to plug in the value of 0. So I have negative 5 equals negative 2 cosine at 0 plus c. Cosine at 0 is 1. So negative 2 times 1 plus c equals negative 5. Okay, now I have negative 5 equals negative 2 plus c. C therefore equals negative 3. Okay, so what does my initial condition look like? Y equals negative 2 cosine radical t minus 3. Okay, so that is the initial condition. That's what c is. And now I'm done. Okay, we have one more problem. The remainder antiderivatives of the basic trig functions can be derived using substitution methods. For instance, you know, the integration of tangent x dx equals the natural log of the absolute value of secant x plus c, which also equals negative the natural log of the absolute value of cosine x plus c. The integration of cotangent x dx is equivalent to the natural log of the absolute value of sine x plus c. The integration of secant x dx equals the natural log of the absolute value of secant x plus tangent x plus c. And then finally, the integration of cosecant x dx equals the natural log of the absolute value of cosecant x minus cotangent x plus c, which is equivalent to the negative natural log of the absolute value of cosecant x plus cotangent x plus c. So the following says, hey, prove it. So we're going to look at the first one, and we're going to prove that the integration of tangent x dx is equivalent to the natural log of the absolute value of secant x plus c. Okay, so first of all, I'm going to rewrite tangent x dx in terms of sine and cosine. So if I do that, I get the integration of sine x over cosine x dx. Okay, so if I have a quotient, remember I can't integrate that as it stands, so I need to rewrite it. So if I rewrite it, I can rewrite this as the integration of sine x times 1 over cosine x dx. Furthermore, I can go on to say this is sine x times cosine x to the negative 1, okay, dx. All right, so if I have this raised to the negative 1 power, I'm going to rewrite this again just so cosine x is first, and I'm going to use substitution. Okay, so if I use substitution, I can let u equal cosine x, so therefore du equals sine x. Okay, and these two match up. The leftovers match up, so we're in good shape. Just forgot to put dx there. All right, so let's write this up. The integration of u raised to the negative 1 of dx, or du, excuse me. All right, and we know that u raised to the negative 1 power, the integration of that is going to be ln of u. And guys, I forgot the negative sign right here, so I'm going back and fixing this really quick. Remember when you take, and I'm going back to the substitution, and I'll write this out in a second, but I forgot a negative sign. So if u equals cosine x, du equals negative cosine x dx, I have to make them match, so I'm going to multiply everything by negative 1. Okay, so negative du equals sine x dx. All right, so I should have a negative sign hanging out here. Sorry about that. Now I wrote out what it's supposed to be. I'm ready to integrate it. So u to the negative 1, I hope you guys said it's ln of u, which is right. So this is negative 1 times ln of u plus c, right? So now we do back substitution. Remember, u equals cosine x. So we have negative ln of cosine x plus c. And you might be saying, yeah, that's great. So you're showing me that this piece is true up here. How about this piece right here, this ln of secant x plus c? Okay, hopefully you remember your logarithm rules. So remember that ln of a raised to the p power is equivalent to p times ln of a, right? And if I do that, I can rewrite ln of cosine x raised to the negative 1/2 power, right, plus c. Now, if I rewrite this, this means ln of 1 over cosine x, right, plus c. And 1 over cosine, by definition, is going to give me secant x. So that's how those three are equal to each other. Okay, so we just got that last piece of information. All right, guys, so that's the end of 5.5 part 3. Please make sure you upload your notes to Canvas, and that's it.